We're now looking at confidence intervals for proportions instead of for means. So it's the same general idea. We're going to have to calculate a margin of error, then add and subtract that margin of error from our sample proportion. The one extra thing that we're going to have to do is we're going to have to calculate that sample proportion p hat by taking x over n, the same way that we've had to do in the past when working with proportions. Margin of error formula is slightly more complicated. It still includes that z alpha over 2 with the same three common numbers that we'll be seeing for 90, 95, and 99%. But now instead of being multiplied by sigma over root n, it's multiplied by the root of p hat times 1 minus p hat over n, all happening under the square root. So the most confusing part of this is definitely making sure that everything's entered correctly for this part. But I'm going to work through 3 of these, show you how to find the margin of errors, and then use those 3 margin of errors to find confidence intervals just by taking p hat minus margin of error and p hat plus margin of error. So where we're going to start is here in number 1 by calculating p hat. That's going to be based off x 72 divided by n 80. If I put that in my calculator, 72 divided by 80, that gives me 0.9. Now that I have my p hat, I can set up my margin of error to be z alpha over 2. For 99%, that'd be 2.575 times the root of 0.9, 1 minus 0.9, all over n, which in this case was 80. When I put this into my calculator, 2.575 times parentheses, the root of parentheses, 0.9 n parentheses, new parentheses, 1 minus 0.9 n parentheses divided by 80 n parentheses. So again, make sure this 80, make sure all this stuff is happening under the root. Parentheses are very important here. When I put all of this in, I get 0.086. Applying the same ideas to number 2, I start out by finding my p hat, 28 divided by 150. When I put that in, 28 divided by 150 gives me 0.186 repeating. So I'm going to call that 0.19. It tells me I want to be 90% confident. That points me to a z alpha over 2 value of 1.645. I multiply that by the root of 0.19, 1 minus 0.19, all over the n of 150. When I put that in my calculator, 1.645 times parentheses, the root of parentheses, 0.19, n parentheses, new parentheses, 1 minus 0.19, n parentheses, divided by 150, n parentheses on the root. When I do all that, I get 0.053. For number 3, I start out calculating 35 over 62. 35 over 62 gives me 0.5645, which I'm going to call 0.56. Since I'm 95% confident, that points me to a value of 1.96, which is going to be multiplied by the root of 0.56, 1 minus 0.56 over 62. When I put that all in my calculator, 1.96 times the root of parentheses, 0.56, 1 minus 0.56 divided by 62, all under the root. That gives me 0.124. Really, it was 0.1235, but since I'm dropping the 5, I round up to the 4. So this was all the hard work to get to this margin of error. When I'm doing 4, 5, and 6, all it's asking me to do is take that margin of error in conjunction with the p hat that I also found and use them to create the confidence interval. So in number 1, we had a p hat of 0.9. For number 4, when I find the confidence interval, I'm going to start with that 0.9. In number 1, we found that the margin of error was 0.086. So that's what I'm going to start by subtracting. And then I'm going to take that same 0.9 and add 0.086. When I put that in my calculator, 0.9 minus 0.086 gives me 0.814, and when I do 0.9 plus 0.086, that gives me 0.986. So in this case, we're 99% sure the true population proportion lies between 81.4% and 98.6%. For number 5, same idea, start with that 0.19. We're going to subtract, then we're going to add the margin of error, in this case 0.053. When I subtract, 0.19 minus 0.053 gives me 0.137. When I add 0.19 plus 0.053, that gives me 0.243. So in this case, we're 90% sure the true population proportion lies between 13.7% and 24.3%. For the final one, number 6, we started our p-hat of 0.56. We're going to subtract and add 0.124. When I subtract 0.56 minus 0.124, I get 0.436. When I add 0.56 plus 0.124, I get 0.684. So the true population proportion, we're 95% sure that it lies between 43.6% and 68.4%.